Hello and good morning to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss optimal page replacement algorithm. Optimal page replacement algorithm is the best page replacement algorithm of all the page replacement algorithms because optimal page replacement algorithm results in least number of page faults. Here, the page is replaced if it will be not referred to for the longest duration of time in future. In simple terms, here a page is selected for replacement if it is not referred to for longest duration of time in future. In simple context, the page that will be referred farthest in future are replaced in this algorithm. Upon drawing an understanding of optimal page replacement algorithm, here we can conclude that the effectiveness of optimal page replacement algorithm heavily relies on the ability of the forecasting technique. Here, the request to the pages are to be known in advance in order to facilitate optimal page replacement algorithm to make quality decision. So again, I'm repeating it, the overall effectiveness of optimal page replacement algorithm heavily relies on the ability of forecasting the requirement of page at future point in time. Now let us discuss some of the advantages and disadvantages of optimal page replacement algorithm. Optimal page replacement algorithm is computationally simple and efficient. It is easy to use and simple to understand. Moreover, optimal page replacement algorithm is often used as a benchmark for comparing the performance of other algorithms. Now let us go through some of the disadvantages of optimal page replacement algorithm. Optimal page replacement algorithm, as said, it requires forecasting of needs at future point in time. Now forecasting would definitely incur greater amount of time because additional computation is required, and in addition to that, forecasting may not be possible in all kinds of system. For an example, in case of real-time system, when the need is generated at real time, forecasting may not be possible. So here optimal page replacement algorithm cannot be applied to all kinds of system. So definitely, as I've already said, optimal page replacement algorithms consumes greater amount of time because it not only performs replacement but it performs replacement based on forecasting, which would definitely incur additional time and computational complexity. Now let us try and understand optimal page replacement algorithm with the help of a very simple example. So here I'm considering that there are 4 frames and there is a page reference string as specified below. So here the page reference string basically refers to or represents the sequence in which the pages are requested for in due course of time. As in case of FIFO, P here represents page, H here represents page hit, M here represents page miss, F1 to F4 represents the 4 frames. As discussed earlier, page hit refers to a condition when the requested page is found in the memory, and page miss refers to a condition where a requested page is not found in the main memory. So hit and miss here for simplicity is represented using asterisk and hash respectively. So let us start with the steps that are involved in optimal page replacement algorithm. For simplicity and for forecasting, I have placed the page reference string below the 2-dimensional representation. So along the 2-dimensional representation, we have the 4 frames, we have the page, we have page hit and page miss, and below the 2-dimensional representation I have the page reference string placed in order to facilitate forecasting. Now let us start with the replacement. So initially there is a request for page number 1. So since page number 1 is not available in the memory, the page number 1 has to be loaded from the secondary storage to the main memory. So there is a page miss. Now likewise, after 1 there is a request for page number 0. Since page number 0 is not available in the memory, it has to be loaded into the main memory. Again we have a page miss. Then after 0 there is a page request for page number 2. So since page number 2 is not available in the memory, page number 2 is brought into the main memory. Again we have a page miss. Then after 2 we have a request for page number 4. So page number 4 is not available in the memory, so page number 4 is bought into the memory. Again we have a page miss here. So for these initial 4 pages, which are 1, 0, 2, 4, we need to simply place the page from the secondary memory onto the main memory, and it does not call for any replacement because the frames were initially empty. Now since the frames are fully occupied, so any page that is to be bought into the main memory has to be done through replacement. Now here we have made a request for page number 8. So since page number 8 is not available in the memory, I need to replace either of these 4 frames, which are 4201, by the frame by the page that is being requested for. So on analyzing the page reference string, we see that 201 has a closed reference, whereas 4 has a farthest reference. So since 4 has the farthest reference, we'll replace 4 by 8. Now after 8 there is a request for 9. So since 9 is not available, so any of the 4 frames are to be replaced. So out of 8201, if we see, 201 has the closest reference and 8 has the farthest reference. So now what I need to do is I need to replace 8 with 9, and after 9 we have a page request for 5. So since page number 5 is not available in the memory, so I need to replace either of these 4 pages, 9201 with 5. So on analyzing the page reference string, you see that you have a close reference to 201 and you have farthest reference to page number 5. So 9 and page number 9. So 9 will be replaced by page number 5. So this is the way how this algorithm works. Now there is a reference to page number 2. So page number 2 is available in the memory. So there we have a page hit. So in situation when there is a page hit, we need not perform any replacement. Now after 2 there is a reference to page number 13. So since page number 13 is not there in the memory, it has to be bought into the memory by replacing either of the 4 pages, which are 5201. So if you closely analyze, you have a close reference to 0, 1 and 5, but since there is no reference to page number 2, we'll consider that we have a farthest reference to page number 2. So page number 2 will be replaced by page number 13. Then we have a reference to page number 0. So page number 0 is available in the memory, so we have a page hit, no replacement is required. Now likewise we have a reference to page number 1. So page number 1 is available in the memory, so there is a page hit. So since there is a page hit, no replacement is required. Then after that we have a reference to page number 11. So since page number 11 is not available in the memory, so we need to bring page number 11 into the memory by replacing either of the 4 pages, which are 5, 13, 0 and 1. So out of 5, 13, 0 and 1, we have close reference to 5, 1 and 0, but we do not have a reference to 13. So we'll assume that we have a farthest reference to 13. So 13 will be replaced by 11. After 11 we have a reference to page number 4. So page number 4 is not available in the memory, so we need to replace either of these 4 frames, 5, 11, 0 and 1, by 4. So on analyzing the page reference string, we find that there is a close reference to 11, 5 and 1, and we have farthest reference to page number 0, so 0 will be replaced by 4. After 4 we have a reference to page number 9. So page number 9 is not available in the memory, so we need to load page number 9 into the memory. So on closely analyzing the page reference string, you see that there is a close reference to 5, 4 and 1, but there is 11, 5 and 4. So there is a farthest reference to page number 1, so page number 1 will be replaced by page number 9. After 9 there is a reference to page number 11. So since page number 11 is available in the memory, we have a page hit. So since there is a page hit, we need not perform any replacement. After 11 there is a reference to page number 12. So since 12 is not available in the memory, we need to bring 12 into the memory by replacing either 5, 11, 4 or 9. So if you analyze the page reference string, you see that you have a close reference to 9, 5 and 4. But you do not have a reference to 11, so we'll consider that we have a farthest reference to 11, so I'll replace 11 with 12. Now there is a page reference to page number 9, so since 9 is already available in the memory, we have a page hit. So since there is a page hit, I need not perform any replacement. After 9, there is a reference to page number 8. So since page number 8 is not available in the memory, so I need to suitably replace either of these 4 pages, 5, 12, 4 and 9, by page number 8. So on analyzing the page reference string, there is a reference to 5, there is a reference to 4, but there is no reference to 12 and 9. So what I'll do is I'll replace the oldest page, that is page number 9, by page number 8. After 8, there is a reference to page number 5. So since page number 5 is already available in the memory, so we have a page hit. Since there is a page hit, no replacement is required. After 5, we have a reference to 4. So 4 is already available in the memory. So again, we have a page hit. So no replacement is required. After 4, there is reference to 8. So 8 is already available in the memory. So we have a page hit. So since there is a page hit, no page replacement is required. Then we have a reference to page number 3. So now in the page reference string, we do not have a reference to either 5, 12, 4 and 8. So what I'll do is I'll replace the oldest page. So the oldest page here is 5, so 5 will be replaced with 3. Likewise, I have a reference to 1. So what I'll do is I'll replace the oldest page. So the oldest page is page number 4, and eventually I have a reference to page number 0. So oldest page amongst all are 8. So 8 will be replaced with 0. So this is the way how optimal page replacement algorithm tries to perform replacement. So in today's class, what we have learned about is we have learned about how optimal page replacement algorithm works, why it's considered to be the best algorithm, and what are the inherent processes that are involved in optimal page replacement algorithm. Then we talked about some of the notable advantages and disadvantages of optimal page replacement algorithm, and then we tried to understand optimal page replacement algorithm with the help of a very simple example wherein we try to create a reference to pages for determining the number of page hits and page miss. Now further, here as in case of first in first out, we need to compute the total number of page hits and total number of page miss. So here the total number of page hit we have is 8, and the total number of page miss we have is 16. So page hit ratio will be 8 by 24 into 100, that will be around 33.33, and page miss ratio will be 16 by 24 into 100, that will be around 66.66. So this is the way how page hit and page miss is further calculated in case of optimal page replacement algorithm. In the next class, we will discuss least recently used page replacement algorithm, and eventually we'll discuss last in first out page replacement algorithm. Till then, thank you very much. Have a good day.